Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corn. We've chatted about ZFS before, and these multi-disk file systems are just works of technical art. The more you learn about how much work they do in terms of checksum and metadata verification, and these file systems like BTRFS, XFS, ZFS are basically what's holding the world's data together when we think about what companies like Meta are using in their data centers. They're not even using ext4, they're using these file systems. So recently I had a home server that failed, as we talked about in a few episodes, looking at the different aspects of hardware failure and how to prepare oneself against that. But ZFS kind of, I wouldn't say saved the day, because I still had to build a new computer. It's not going to do anything if the hardware fails. But it was able to preserve the data perfectly. So when the old server failed, I was able to pull out it was 4 SSD drives, put them in an anti-static bag. And what I'd like to chat about in today's podcast is ZFS recovery, because there were two paths, and I'll explain the path I ended up taking. So the easier path, which is what I didn't do, but it was tempting, is to just, if you do have hardware failure, but your storage is good, so you build your whatever new hardware, you replace the part that failed, and then you just connect the disks. Now the problem is that if the hardware changes around it, like you've got a new CPU, you've got a new parts, that process isn't necessarily easy because the system has fundamentally changed, and that's where I ran into difficulties. What I actually ended up doing was importing the pool, saving the pool by connecting those 4 disks to a working system, importing the ZFS pool, keeping that on an external SSD. Then when I had the new system built, this was Proxmox, I recreated a blank ZFS pool, and then I imported from the SSD. So that was the recovery process I actually ended up using in practice. My question to Herman and Corn is regarding ZFS recovery. Is it possible to do a direct plug and play? In other words, if you just move on to completely new hardware, you can just keep your disks, connect them, and that'll work. Because what I found was there were just a lot of very messy boot errors that I figured it would probably be quicker to just do it this way. But I'd like to know what the more professional approach might have been, or what the professional approach is for ZFS pool recovery. If you do find yourself running a small business or even a home server environment, you have a ZFS pool, some of the hardware fails, what would be the best backup to have on hand for precisely this type of recovery situation?
Hey everyone, welcome back to My Weird Prompts. I am Corn, and we are coming to you from our home in Jerusalem for episode 610. I have to say, the energy in the house has been a little bit different lately because our housemate Daniel has been dealing with some major technical headaches.
Herman Poppleberry here, and yes, the server room, which is basically just a closet with a lot of fans, has been a place of high drama. Daniel was telling us about his home server failing recently, and it really sparked a fascinating deep dive into one of my absolute favorite topics, the ZFS file system.
It is a classic scenario that every home lab enthusiast or small business owner dreads. You hear that sudden silence of a fan stopping, or you see the dreaded kernel panic on the screen, and your first thought is my data gone? Daniel managed to save his data, but the process of moving those disks to new hardware was not as seamless as he hoped. He asked us today if a direct plug-and-play move is actually possible with ZFS, what the professional recovery path looks like, and how to build a backup strategy that makes this whole thing less of a heart attack.
It is such a timely question because as more people move away from simple external hard drives and towards sophisticated network-attached storage or virtualization platforms like Proxmox, they are encountering ZFS for the first time. And ZFS is a beast. It is a combined file system and logical volume manager that was originally designed by Sun Microsystems for Solaris. It is meant to be the last word in data integrity.
Right, and most people know it for its ability to handle massive amounts of data and protect against bit rot. But when the hardware around those disks dies, the portability of the pool becomes the biggest question. So, Herman, let's start with Daniel's core question. Is ZFS truly plug and play? If my motherboard fries, can I just take my 6 drives, plug them into a brand new machine with a different CPU and a different controller, and expect my data to be there?
The short answer is a very enthusiastic yes, but with a few very important caveats that usually trip people up. Architecturally, ZFS is incredibly hardware agnostic. This is one of its greatest strengths compared to old-school hardware, RAID. In the old days, if your RAID controller card died, you often had to find an identical card with the same firmware version just to read your disks. With ZFS, the disk layout and the metadata are stored on the disks themselves. The software does all the heavy lifting. So, you can move a ZFS pool from an Intel system to an AMD system, or even from a physical machine to a virtualized one, and it should work.
So why did Daniel have such a hard time? He mentioned messy boot errors and having to go through a multi-step process of importing and exporting. If it is hardware agnostic, why isn't it just like plugging in a USB thumb drive?
That is where the distinction between a data pool and a boot pool comes in. If you are trying to move the entire operating system that is running on ZFS, you are going to run into all the standard issues of hardware drivers, mount points, and host identifiers. When Daniel moved his drives, the new system likely saw those disks and said, "Hey, I see a ZFS pool here, but it looks like it belongs to another system." ZFS has a concept called the host ID. When you create a pool, it is essentially locked to that host to prevent two different computers from trying to write to the same disks at the same time, which would obviously cause catastrophic corruption.
That makes sense. It is a safety feature. But if the original host is a smoking pile of silicon, how do you tell the new host that it is okay to take over?
This is where the professional recovery workflow begins. In an ideal world, before your hardware dies, you would run a command called zpool export. This cleanly unmounts the file system, writes the final metadata to the disks, and marks the pool as exported. When a pool is exported, any other ZFS system can see it and say, "Okay, this is available for me to import." But, like in Daniel's case, when the hardware crashes, you never get a chance to export. The pool is left in a state where it thinks it is still owned by the dead machine.
So you are sitting there with your new hardware, you plug the drives in, and you run the import command and it gives you an error. What is the next step for a professional?
You use the force, corn, literally. The command is zpool import-f. The -f stands for force. This tells the new system, "I know this pool looks like it belongs to someone else, but I am telling you that I am the new owner." Now before you do that, a professional isn't just going to guess. They will run zpool import without any arguments first. This will scan all the connected drives and list every pool it finds, showing you the name, the ID, and the status. It might say something like status online, but then give a warning that it was last accessed by another system.
I imagine that is a very tense moment for a sysadmin. You are looking at that list, hoping your pool shows up as online, or at least degraded, and not faulted.
Exactly. If it says faulted, you have a bigger problem, likely physical disk failure. But if it is just a host mismatch, the force import usually clears it right up. One thing that probably tripped Daniel up, especially since he mentioned using Proxmox, is how the system identifies the drives. If your old system used simple device names like /dev/SDR or DB, and your new system assigns different letters because the controller is different, ZFS can sometimes get confused. The professional approach is to always import by IDD. You point ZFS to a directory like /dev/disk/by-id. These are unique serial numbers for the drives themselves. That way, it doesn't matter which port they are plugged into or what the operating system calls them, ZFS finds its members based on their unique identities.
That feels like a huge takeaway for anyone setting up a home server right now. Don't rely on star or DB. Use the unique IDs. But let's talk about the boot errors Daniel mentioned. He said he ended up recreating a blank pool and importing data from an external SSD. That sounds like a lot of work. Was there a way he could have avoided that?
It sounds like Daniel was trying to recover his entire environment, not just his files. In a professional small business environment, we usually separate the operating system from the data. You have your boot drive, which might be a simple mirrored pair of small SSDs, and then you have your massive ZFS data pool. If the motherboard dies, you don't really care about the boot drive. You can reinstall the OS in 20 minutes. The magic is in the data pool. If Daniel had a clean separation, he could have just reinstalled Proxmox on the new hardware, run that zpool import-f command, and all his data, his virtual machine images, and his backups would have appeared instantly.
So, the messy errors were likely because the new operating system was trying to resolve old paths or old hardware configurations that simply didn't exist anymore. It is like trying to put a human brain into a robot body, and the brain is still trying to wiggle toes that aren't there.
That is a great analogy. The brain, or the OS, is looking for the specific network card or the specific disk controller it had before. If you just want your data back, don't try to boot the old OS on new hardware unless you absolutely have to. Treat the new hardware as a fresh start and just import the data pools. Now, let's talk about why ZFS is so good at this compared to other systems. It uses something called a copy-on-write transactional model. Every time you write data to ZFS, it doesn't overwrite the old data. It writes the new data to a fresh block and then updates the pointers. This means that if the power cuts out or the motherboard fries mid-write, the old data is still there. The file system is almost always in a consistent state. You don't have to run those long, terrifying file system checks like you do with older systems.
That is incredible for peace of mind. But even with all that protection, hardware can still fail in ways that ZFS can't fix, like if you lose too many drives at once. Daniel asked about the best backup strategy for these recovery situations. If ZFS is so robust, do you even need a traditional backup?
Oh, Corn, you know the answer to that. Redundancy is not a backup. RAID, or in this case RAIDZ, protects you against a disk failing. It does not protect you against a fire, a flood, a ransomware attack, or even just accidentally typing the wrong command and deleting your most important folder. For a professional or a serious home user, the gold standard is the 3-2-1 rule. 3 copies of your data on 2 different media types with 1 copy off-site.
And ZFS actually has some built-in tools that make the 3-2-1 rule much easier to implement than with other file systems, right? I have heard you talk about snapshots and replication.
This is where ZFS really pulls ahead of the pack. Most people think of a backup as a giant copy-paste operation that takes hours and slows down your network. With ZFS, we have snapshots. A snapshot is a point-in-time view of your file system. Because of that copy-on-write model I mentioned, creating a snapshot is instantaneous. It takes 0 extra space initially because it just keeps the old pointers to the data that was there at that moment.
So if I take a snapshot at noon and I delete a file at 12:05, the file isn't actually gone from the disk?
Exactly. The snapshot still points to those blocks. You can roll back the entire file system to noon in a fraction of a second. But a snapshot on the same disk isn't a backup because if the disk dies, the snapshot dies too. That is where ZFS send and ZFS receive come in. These commands allow you to take a snapshot and turn it into a stream of data that you can send over the network to another ZFS machine.
Is that different from something like rsync, which a lot of people use for backups?
It is fundamentally different and much more efficient. rsync has to scan every single file on both sides, compare them, and then decide what to move. If you have millions of files, that scan can take hours. ZFS send doesn't need to scan. It already knows exactly which blocks have changed since the last snapshot. It just sends those specific blocks. With modern OpenZFS features like block cloning, which became standard in version 2.2, these transfers are even more efficient because the system can track cloned blocks without resending the data. It is incredibly fast, it is atomic, and it preserves all your metadata, permissions, and compression.
So, in the professional recovery setup, you would have your main server, and then maybe a cheaper, larger server sitting in another room or another building. Every hour, your main server takes a snapshot and sends the incremental changes to the backup server.
That is exactly it. And because it is so efficient, you can keep a very high frequency of backups without impacting performance. If your main server hardware dies, you don't even have to worry about the import-f command if you don't want to. You can just point your users or your applications to the backup server, which already has an identical copy of the data. That is what we call a low recovery time objective, or RTO.
That sounds like the dream setup. But what about the off-site part of the 3-2-1 rule? For a small business or a home user, setting up a second server in a different city might be too expensive or complicated.
This is where the modern cloud comes in, but with a ZFS twist. There are services like rsync.net or others that actually give you a ZFS target in the cloud. You can use ZFS Send to stream your snapshots directly to their servers. Your data stays in its native ZFS format, encrypted at rest, and you have that ultimate off-site protection. If your whole house or office is lost, you just get a new machine, install ZFS, and pull your data back down.
I want to go back to the professional approach for a second. If you are a small business and you are relying on ZFS, what are the things you should be doing right now, today, to make sure that if your hardware fails tomorrow, the recovery is as smooth as possible?
Number 1, label your disks physically. It sounds silly, but when you have 8 identical-looking drives in a chassis and one of them is throwing errors, you don't want to be guessing which one to pull. Match the physical label to the serial number in your ZFS pool. Number 2, keep a printed copy of your pool configuration and your disk IDs. If the system won't boot, you want to know exactly what the layout was. Number 3, test your backups. A backup is just a theoretical concept until you have successfully restored from it. Every few months, try to restore a single folder or a virtual machine from your snapshots.
And what about the hardware itself? Daniel mentioned he was using 4 SSD drives. Does the choice of hardware affect how recoverable a ZFS pool is?
Absolutely. One of the biggest mistakes people make in home servers is using consumer-grade hardware that lies to the operating system. Some cheap disk controllers, or SSDs, have volatile caches that tell the OS data has been written to the disk when it is actually still sitting in a temporary memory buffer. If the power goes out, that data is lost, and it can lead to what we call write-hole issues. For a professional setup, you want a host bus adapter, or HBA, in IT mode. This means the controller doesn't try to do any RAID logic itself, it just passes the disks directly to ZFS. And you want SSDs with power loss protection, which have little capacitors that provide just enough power to flush that cache to the disk if the lights go out.
It is interesting how much of the professional approach is about removing layers of abstraction. You don't want a fancy RAID card. You don't want the OS to be doing clever tricks with the drive names. You just want ZFS to have a direct, honest conversation with the hardware.
That is the perfect way to put it. ZFS is designed to be the single source of truth. When you add other layers of truth, like a hardware RAID controller or a virtualization layer that hides the true nature of the disks, you are creating blind spots. If ZFS can't see the health of the individual disks, it can't do its job of protecting you from bit rot or predicting a failure before it happens.
So, to summarize for Daniel and everyone else listening who might be facing a server move, yes, you can just move the disks, but don't try to boot the old OS. Install a fresh OS, use the zpool import-f command, and always identify your disks by their unique IDs rather than their device letters.
And remember that the move itself is a high-stress event for the hardware. Often, a drive that was working fine while spinning constantly will fail when it is powered down and moved to a new cold environment. That is why having that ZFS send backup on a different machine is your ultimate safety net. It takes the pressure off the recovery. You aren't sweating over the disks because you know the data is safe elsewhere.
I think people also get intimidated by the command line nature of ZFS. But there are some great tools now that wrap a GUI around it, like TrueNAS or the ZFS plugin for Unraid or Proxmox. Do you think those are suitable for a professional environment? Or should you stay in the terminal?
Those tools are fantastic. TrueNAS, in particular, is essentially built on top of ZFS. It handles the snapshots, the replication, and the monitoring for you. But, and this is a big but, as a professional, you should still know the underlying commands. If the GUI won't load because the system is in a boot loop, you need to be able to drop into a shell and run zpool status. That command is your best friend. It tells you exactly which drive is acting up, how many checksum errors have occurred, and if the pool is currently scrubbing.
A scrub. We haven't talked about that yet. That is another key part of the professional maintenance routine, right?
It is the most important routine. A ZFS scrub is when the system reads every single block of data on the disks and verifies it against the stored checksums. If it finds a block that has been corrupted by bit rot, it automatically uses the parity data from the other disks to repair it. In a professional setting, you should schedule a scrub at least once a month. It is like a self-healing checkup for your data.
It is amazing how much engineering has gone into making sure that a 0 stays a 0 and a 1 stays a 1. I think we sometimes take it for granted, but when you realize that background radiation or a tiny manufacturing flaw in a disk can flip a bit and ruin a wedding photo or a critical business spreadsheet, you start to appreciate the obsession with checksums.
It really is a beautiful system. And for anyone who thinks this is overkill for a home server, just think about the value of your data. We are generating more data than ever before. Our photos, our videos, our tax records, our creative work. Putting that on a single external drive with no checksumming is like building a house on sand. ZFS is the bedrock.
Well, I think we've given Daniel a lot to think about for his next server build. It sounds like he actually did the right thing by importing the data into a fresh Proxmox install, even if it felt like a roundabout way to get there. He avoided the headache of trying to fix a broken boot environment and went straight for the data integrity.
Exactly. He took the long way, but it was the safe way. And now that he has that new hardware, he can set up those automated snapshots and feel a lot more secure the next time a fan decides to quit.
Before we wrap up, I just want to say, if you're finding these deep dives into the plumbing of the internet and our home labs useful, we'd really appreciate it if you could leave us a review on Spotify or whatever podcast app you're using. It genuinely helps the show grow and lets more people find us.
Yeah, it makes a huge difference. And if you have your own technical horror stories or weird prompts, head over to myweirdprompts.com and use the contact form to let us know. We love hearing what you're working on.
Thanks for joining us for episode 610. We'll be back soon with more from the house here in Jerusalem. This has been My Weird Prompts.
Until next time, keep your pools healthy and your scrubs regular. Goodbye.
Bye. Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.